The Analysis button helps us compute various part and assembly properties in our model. To see this button and not have it grayed out, we first have to select on a part or assembly. So in this case, I'll simply drag out a simple block from our catalogue, and now you can see when we have that selected, we have the Analysis button available. I'll now click on that, and we can now see the Analysis window. There are 3 tabs here. We can see the Shape tab, which allows us to calculate the material properties like the mass and the volume, and also the center of gravity. We have the Surface tab here, which allows us to calculate the surface area of the model, and then we have the Moments of Inertia tab, which allows us to calculate the moments of inertia. To start, let's go back to the Shape tab, and I'll explain some of the different options here. To see these values, we first need to click on Compute, and then we can see the various values showing here. But these can be customized by these 2 options here. The coordinate system affects the center of gravity position, and the options are either the world coordinate system or the selected shape local coordinate system, in other words, the anchor. So when you drag and drop out a shape from the catalogue, by default it will be placed in the 0, 0 point of your new scene, if it's a brand new fresh 3D scene. But then if you drag out a new shape, it will be placed not on the 0, 0 point, just in random space wherever you happen to drop it. So I'll show you what I mean by that, because of course, as you can see with this part, the center of gravity is currently 0, 0, and then 13.889. So that's the x-axis, the y-axis, and the z-axis. 0 on the x, 0 on the y, 13.889 on the z. And because when you drag and drop something out of the catalogue, the anchor is where you place it, the world coordinate system and the shape local coordinate system will be the exact same value for the time being, but they will change in a moment. So now what I'll do is I'll drag out a second block over here. Now this block is in random space, not at the 0, 0 point of our model. And a good way to see the 0, 0 point of the model is to right-click an empty space and click on Show. You can then turn on Position Dimensions, which will show the position of each part in the model. Now if you click on a part, you can see the various position dimensions to the part anchor. So it goes from the 0, 0 point of the model to the part's anchor. And it's worth noting you can click on this anchor and move it. So on this part, I'm going to move it to this top right corner here. So it's worth noting that those positions are calculated using the anchor and not the part. So the anchor doesn't necessarily need to be on the part's geometry. It can be near it or next to it or anywhere you like. So now let's have a look at that analysis window again. This time I'll do it for this part. I'll click on Analysis, click on Compute. As you can see, the center of gravity relative to the world coordinate system is quite different, because now the center of gravity is being based upon these values here. Then if we click on Selected Shape Local Coordinate System, you can see the values are different again, because now it's calculating the center of gravity measured from this anchor point. I'll show you another example here where we move this anchor point to the same position the other one is in, which is at the center of the block here. So that's the same position this anchor point's in, although this one is just different on the world coordinate system instead of being at 0, 0. So now you can see if we select on this and compute it, again we'll have a different value because it's being based off the world coordinate system. But if we click on the local value will be exactly the same as we saw for this part, because now the center of gravity is being calculated based off the position of that anchor again. So it's now 0 on the x-axis, 0 on the y-axis, and 13.889 upwards on the z-axis. Because as you can imagine, center of gravity is somewhere in the middle of that block there. But what matters is whether or not we're choosing to use the world coordinate system to dimension that center of gravity, or using the local coordinate system to dimension it. So where would we like to measure from for that center of gravity? Now on to the next one here for material properties. We can either use the individual part density values in the computation, or we can use a custom density value. Now if you have an assembly with many different material types, of course using the individual part density values will generally be a much better option. But if you have a material model that's made all out of the same material, you can also just set custom materials in here if you want to as well. So, for example, let's go ahead and change the material. Let's add a aluminium to this model, and then a stainless steel to this model. So naturally, this one will be a lot heavier than this one. Now if we go ahead and we click on this model, click on analysis, you can see the density is using the individual part density, which is 8,000. And if we go in here, click on this model, analyze that one, it's using the individual part density, which is 2,700. Now if we select on both of those, or we assemble those, so that we can select them both and do an analysis on the assembly, we can then see that the density value is not showing here in the custom because it's different for the individual parts. So that's why it's not showing a set same value for everything, because it's going to be different. Therefore, the value for the mass is going to be different if we use the individual part densities, because there's an aluminium and stainless steel, or if we use the custom density value. So let's change it to custom density. And so you can see it's currently 0.578. Let's say both parts were aluminium, then we could change this to 2,700, and it would disregard the individual part density value of the stainless steel item. And we can recompute that, and we can see it's now lighter for the overall assembly mass. Another thing to note, that when you have an assembly, the anchor for the assembly is now different to the anchor of the part. Every item in IronCAD has a separate anchor. So, for example, you have an anchor for the assembly, and then you have an anchor for the individual part. Anchor for this part, and then again, anchor for that assembly. We also have an anchor for the shape as well. So the anchor that is being used is the anchor at the level you're selected onto. So if we go ahead and we move this assembly anchor, which is currently at 0, 0, we can now move it off into the distance really far, just for fun, so we get a crazy value showing. So now we'll click on the assembly, click on analysis, and now when we compute this, we get the center of gravity from the world coordinate system is pretty simple. It's just 50 millimeters minus 25 and then 50. So it's somewhere in the middle of those two items there. But then if we change this to the local coordinate system, you can see this is going to be now strange, like it's got the minus 443, because the anchor is all the way over here, and it's using that as its measurement for the center of gravity. Okay, now let's have a look at the surface tab here, which is pretty simple. You just click compute, and that'll compute all the surface area on your model. Now we'll go over here to the moments of inertia, and we'll click compute on those. You can note again, you have the same options here, the coordinate system options, which you can customize. So you can either choose the world coordinate system, or you can use the selected shape local coordinate system. And you can see the moments of inertia can be calculated with the center of gravity of the model. So that's going to always be in the same spot no matter where your anchor is. The center of gravity is going to be in the same spot every time. Or you can use it calculated at the coordinate system origin. So that means it's going to use the anchor to calculate the moments of inertia. So you can see here, we can then move that anchor, so you can see the current values there. And if we have a quick look at some of those values, and then we'll just move this anchor all the way back to somewhere like there. And then we'll do that analysis again. And now we should see very different values there in our moments of inertia when we use the coordinate system origin, because now the coordinate system's position has been changed to here. So it's a good way of knowing where the moment of inertia is being calculated from. We can move that anchor around to calculate the moments of inertia from different places. And again, for the material being used in the moments of inertia, we can either use the individual part densities, like we did before, to calculate the mass, or we can use the custom density value, which is specified for all of the parts in the assembly, or the assembly as a whole. So we could change this to 2700 to say it's entirely made of aluminium, and recompute that. As you can see, the numbers have changed again there. That's how to use the analysis tool.